Record. Hello everyone, today we are going to start chapter 5. The first concept we are going to go over is exponential expression. Exponential expression has two parts. The first part is the quantity on the bottom. The second part is a number on the shoulder of the first quantity. So this number is called the base. And another number is a smaller size number on the shoulder of the base is called the exponent. A here is called the base of the exponential expression. And N here is called the exponent. The exponent of the exponential expression. Two parts. That's how does an exponential expression look like. Exponentiation. This expression describes an operation similar with addition, subtraction, multiplication, division. You see the pattern. And this expression describes an operation is called exponentiation. And exponentiation is a repeated multiplication. Exponentiation as an operation is a repeated multiplication. A to the power of n. This exponential expression refers to a multiplication, a repeated multiplication. In the multiplication, we use the base a repeatedly as a factor in the multiplication. How many times? The number of times we use the base a as the factor in the multiplication is the exponent. In this case, is n. So a to the power of n is the same way we multiply n a's together. So that's the definition of exponential expression. I think the best way to reinforce the understanding is to use it. Let's look at the first question in the worksheet. We're officially in Unit 4. Unit 4 does not cover Chapter 4 in the book. It covers Chapter 5 in the book. We do not cover Chapter 4 in the textbook. Let's look at number 1, number 2. The two expressions are very similar, right? First, you need to see 5 to the power 3 and 3 to the power 5. Those two expressions, they both are exponential expressions because they have the pattern, they have that look. They have a number on the bottom, they have a number on the shoulder of the first number. They have the base, they have exponent. And how do we evaluate an exponential expression? We use the definition. Exponentiation is repeated multiplication. 5 to the power 3. Base is 5. Exponent is 3. So 5 to the power of 3 is equal to, we use 5 as the factor. We use the base 5 as the factor. Multiplication factor in the multiplication. How many times? 1, 2, 3. 3 times. Why 3 times? It is because the exponent on the shoulder of 5 is 3. So we use 5 3 times in the multiplication. And that product is the value of the exponential expression 5 to the power of 3, or 5 to the third power, or 5 cubed. There are multiple ways to describe this exponential expression. 5 times 5 times 5, you can use your calculator. We have 125. That's the value of this exponential expression. Please give the second question a try. This expression is also an exponential expression because it has the look, right? Two parts. And the base in this time is 3. The exponent is 5. So the two expressions are different if you look at it closer. They do both involve the two numbers 3 and 5, but the location of the number place, the role the number plays is different. Yeah, please give the second question a try and tell me what is 3 to the power of 5 means. 3 is the base. The exponent is 5. We call this expression, or we describe this expression as 3 is raised to the 5th power. And let's see what you have. Chat. Awesome. Exactly. Yeah, both Amanda and Felina. Oh, Caitlin forgot a Monday class. It's okay. Welcome to the class on Wednesday. Yeah, 3 times 3 times 3 times 3 times 3. 5 threes multiplied together is 243. Very good. In this time, question number 2, the base is 3, exponent is 5. So we use the base 3 repeatedly in the multiplication. How many times depends on the exponent? 5 times in this case. And use your calculator, 243. Very good. And please give number 3 and number 4 a try. Look at the two expressions. There's a reason I put them together. Then you can compare and contrast. And what's the difference between the two expressions, right? Number 3, question number 3, it is -2 to the power of 4. And the expression in number 4 is -2 to the power of 4. What's the difference between the two expressions? Let me highlight this one as green. Let me highlight the other one as yellow. Are they the same? The green one has a parenthesis. The parenthesis is framing -2, and the number 4 is on the shoulder of the parenthesis. And the yellow one doesn't have any parentheses. Seems like the 4 directly fall on the shoulder of 2. Yeah, please try find the value for the yellow and the green expressions. And let me know, are they the same? Do they have the same values? Try the green first. -2 in the parentheses is raised to the power of 4. Yeah, we're gonna spend time to really understand the difference between the two expressions. They are different, by the way. What's the value for the green? Awesome. Thank you, Jacob. Thank you, Joe. And what's the value of the yellow? The value of the yellow, -16. Awesome. Yeah. The expression in green value is +16. The one in yellow, the value is -16. Let me explain why. The structure. I think I do emphasize the importance of seeing the structure of an expression a lot in this algebra class, right? Here is another example. The structure is very different in the two expressions. In the green, -2 is in the parentheses, and in the parentheses, on the shoulder of the parentheses, we have the power 4. So this indicates the base is -2. We are going to use -2 as the factor in a repeated multiplication. We repeat -2 4 times. The way we use the reason we use parentheses to frame -2 is to indicate -2 is the base. So we are using -2 as the factors in the multiplication. -2 times -2, we have a +4. And this -2 times -2, we have +4. 4 times 4 is 16. All right, it's 16. Positive. And the yellow one is different. In the yellow expression, the negative sign is not part of the exponential expression. Unlike the green one, in the green one, the negative sign is part of the base. The base is -2, not a +2. But in the yellow one, the negative sign is not part of the exponential expression. Then how do we understand the negative sign here? We understand the negative sign as the opposite. It's my way to see the negative sign in front of a quantity. I mentioned this at least a few times before. We see the negative sign here as the opposite. So this expression in yellow means the opposite of 2 to the power 4. You remember that, right? Tell me what's the, so we have number 5. What's the opposite of 5? Simply place a negative sign in front of it. The opposite of 5 is -5. And this can be understood as the opposite of -5. The opposite of -5 is +5. When we place a negative sign in front of a quantity, we understand that as we are getting the opposite of the quantity. So the yellow expression here, we have the negative sign in front of 2 to the power 4. It simply means the opposite of 2 to the power 4. And 2 to the power 4 has the base 2. 2 to the power 4 is 2 times 2 times 2 times 2 is 16. And the opposite of 16, the opposite of 16 is -16. I believe there's other ways to see the structure in yellow, but this is my way to see the structure, and it's a very good way, and I hope you see it as well. Understand the negative sign in the yellow expression as the opposite, kind of like operation, the opposite of 2 to the power 4. 2 to the power 4 is 16. Then the opposite of 16 is -16. That's the reason the two expressions resolve in two different values, because they are two different expressions. Again, in the green one, the negative sign is part of the base. In the yellow expression, the negative sign has nothing to do with the exponential expression. It's not part of the exponential expression at all. Very good. I hope you understand that. We have number 3 is +16. We have number 4, -16. They are different. They are different. This is the base. This concept, exponential expression, and how do we evaluate a given exponential expression is the foundation, the base of the whole chapter. And the first part of this chapter include how many formulas? 1, 2, 3, 4, 5, 6, 7, 8. Involve 8 formulas, and they have their names and they have the rules, and I need you to understand and memorize and know how to apply. We are going to take our time. Don't worry about that. All right, don't worry about that. So instead of I give you the formula directly, I want to start from looking at the application. Let's start from looking at the problem. Look at this problem, number 1 here. The problem I have is to simplify this expression. To simplify this expression. And look at the structure. So today, this chapter, we are going to focus on identifying the actual structure of the given expression. So you're going to have to Be mindful, be aware. Structure, 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 very important. So let's look at the structure of this expression. This structure, the structure of this expression is a multiplication, okay? Yeah, this part times this part. We are looking at a product of two parts. The first part in the bubble, red circle, red bubble, that is an exponential expression because we just went over definition of exponential expression, right? In the first red bubble, we have an exponential expression with the base x, exponent 3. In the second bubble, we have another exponential expression with the base x, exponent 2. Our goal here is to simplify the given expression. So I'm going to use the definition we just went over, the definition of exponential expressions to solve this problem, to simplify this expression. Let's see. X to the power 3. Does x to the power 3 means x times x times x? I believe you agree on that. X cubed, base is x, exponent is 3. Simply means the multiplication of 3 x's. X's. I'm not sure if that is the correct way to pronounce it. It's plural. And x to the power 2 is x times x. Okay, let me color it differently, then you can see what I'm talking about. So the yellow part, I write it out as a repeated multiplication, and the green part, I also use the definition to write it as a repeated multiplication. So the expression right now is x times x times x times x. That itself is a repeated multiplication, right? It is a repeated multiplication. In this repeated multiplication, x is used 5 times. Then we can write this repeated multiplication as an exponential expression, x to the power 5. And that is simple. That is simplified. And that's the result or answer of this problem. Please let me know, do you understand or agree the result? The result is x to the power 5. Do you agree it? We do not use anything new, simply just the definition of exponential expression. Very good. That's the first question. Let's do second question. Number 2. Second question is c to the power 4 times c. I'm going to use my color scheme again. This is the green. This is the yellow. And we are looking at a multiplication of two parts, yellow times green. I'm going to use the same strategy, same way to process number 2 as number 1. We are going to use the definition of exponential expression to rewrite c to the power 4. The yellow is an exponential expression. C to the power 4 means c times c times c times c. 4 c's multiplied together. And then we are going to multiply one more c from the green. The yellow part, by the definition, is that 4 c's multiplied together. And the green part remains the same. It's just the simple factor c. And altogether, we can see, altogether in this multiplication, we have 1, 2, 3, 4, 5. 5 c's multiplied together. And we are able to use the exponential expression to represent this repeated multiplication. And we have c as the base and the 5 to the power 4, 5 as the exponent. 5 as the exponent. C to the power 5. C to the power 5. All right? I think you understand that the two questions are pretty similar. Now we want to discover the pattern, okay? We want to discover the pattern. when we multiply two powers, two exponential expressions with the same base, when we multiply two exponential expressions with the same base, we don't have to every time use the definition to write it out. What if, what if we have a problem has x to the power 102? Are we gonna write 102x, like x? It's gonna take 2 minutes, right? Too many. So we should find a better strategy to process this type of problem, this type of multiplication or product. If the product is the multiplication of two exponential expressions with the same base, then all we need to do is to keep the base, and then what do we do with the do with the exponent? All we need to do is to keep the base and add up the exponents. 3 plus 2 gives us the 5. Okay? If we have a multiplication, it is the product of two exponential expressions with the same base. To save time, we don't have to always write x times x times x and a bunch of x and count the number values. We can just understand it and then simply keep the base x and add up, take the sum of the two exponents. 3 plus 2 is 5. It's pretty easy to understand because 3 here means the first part contribute 3 x's. 2 here means the second part contribute 2 x's. So together 3 plus 2 is the total number of x's in the multiplication. That's the reason the result is x to the power 5th. Similarly, in question number 2, the first part, c to the power 4, the exponent is 4, right? The exponent is 4. That means the first part contribute 4 c's. So we have 4 c's. 1, 2, 3, 4. And the second part exponent is 1. You don't really see the 1, but actually you should know that it's 1. Even we don't have it, it's default as 1. That means the second part contribute 1 c. So together 4 plus 1 gives us the total number of c's in the result. So that's the reason we have c to the power 5. So again, if we need to multiply two exponential expressions with the same base, all we need to do is to keep the base. And then what do we do with the exponents? We add them together. Plus 4 plus 1 here, 5. 3 plus 2 here is 5. Do you understand the reason we added the two exponents? Yes or no? Awesome. If you understand, then please try this on your own. Try this. Y times y7 times y2. Try to simplify this expression. Y times y to the power 7 times y to the power 2nd. Simplify the expression. Y times y to the power 7 times y to the power 2. And what do you have? Y to the power 10. Awesome. Very good, very good. I think you mistyped. Jacob, you mistyped 0 as 9 because they are so close on the keyboard. Right? Exactly. Is y to the power 10. You guys are great. I hope you did not really write a y to the power 7 as a y times 1, 2, 3, 4, 5, 6, 7. I hope you didn't really do this because it works, but it's a lot of work, right? But once you understand y to the power 7 simply means it contributes 7 y's in the result, and y to the power second means it contributes 2 y's in the result, and this means 1 y in the result. Just add the exponents together, 1 plus 7 plus 2, we have the 10. All right, so the rule we have just used, or rule, the rule we have just used, when we multiply two exponential expressions with the same base, we keep the base and add their exponents. That rule has a name. The name is called the product rule. I hope you can remember the name of the rule, product rule, because the kind of the name of the rule tells us when do we use the rule, when do we apply it. When do we apply it? Product, right? We apply this rule when we need to multiply. Product is the result of multiplication. Product rule, we apply the product rule, we need to multiply two exponential expressions with the same base. How do we apply it? We keep the base and add up the two exponents. So the formula is right here. Formula is right here. In general, a to the power of m times a to the power of n equals a to the power of m plus n. So when we have two exponential expressions with the same base need to be multiplied together, we keep the base a and add the two exponents, m plus n. M plus n. All right, I have the rule here. Application rule, application Q. You should memorize and understand this rule. Very important, very helpful. If you remember the Q, it's going to be very helpful. When multiplying two exponential expressions with the same base, we keep the base and then we add the two exponents. One thing might be confusing is how do we process the exponents when we apply the product rule? Seems like product means multiply, but that's to tell us when do we apply. When we apply product rule, we actually need to add the exponents. We do not multiply the two exponents, okay? When we apply the product rule, what do we need to do with the exponents? Actually, is to take the sum, is to add them, All right, guys, help me out with number 3. Right here, we have x cubed plus x squared. We have x cubed plus x squared. It doesn't matter what method you use. You can use the definition or you can use the formula, the rule we have just learned. Tell me, how do we simplify that expression? X cubed plus x squared. X cubed plus x squared. Nope, nope, nope. Let's look at it again. Number 3. Is number 3 and number 1 very similar, but they should be different, right? Because number 1 is multiply. Right here we have a multiplication symbol. And number 3 is addition. Think about this question. Are we able to apply the product rule on question number 3, on the expression number 3 here? Let me amplify. X cubed plus x squared. So the Q, the sentence I wrote here, tells us at least 2 things. First thing, when do we apply the formula, the rule? Second thing is how do we apply it? Especially the first thing, you're going to know when you're going to apply this formula, right? We apply the product rule. Again, the key word here is the product. So we're going to know we apply the product rule when we need to multiply. When we need to multiply two exponential expressions with the same base. Are we multiplying the two exponential expressions with the same base? Or we are adding? Question number 3, we are not multiplying, we are adding the two exponential expressions, right? Yes or no? So, yeah, I want you to see the structure. Yeah, I want you to see the structure. Question number 3, this expression, we do not have a multiplication of two exponential expressions. What we have is an addition of two exponential expressions. So the product rule does not apply. That DNA does not apply, okay? Does not apply. We cannot use the product rule to simplify this expression. And then you might ask, then how do we simplify it? We can't, in fact, we cannot simplify it because it's already simplified. It is already simplified. Why? Because what we have here is the addition or sum of two terms. I hope you still remember what is a term. A term is an expression, is something in which you do not have addition or subtraction. You only have multiplication and division. So x cubed is a term. X squared is another term. Those terms do have coefficients. It's just their coefficient both are 1. It doesn't matter. Doesn't matter to understand what I want to say is the two terms are not combinable. What I want to say is those two terms cannot add together because they are not like terms. Because they are not like terms. Not like terms. The first term coefficient is 1, variable part is x cubed. Second part coefficient is 1, variable part is x squared. They do not have the same variable parts. They are not like terms, so we cannot combine them. Remember, what are like terms? Like terms have to have exactly the same variable parts. They don't, so they are not like terms. We can't combine them, and that's just like that. It's already simplified. My point here is be careful when you apply the product rule. There's a reason I hope you remember the name. It's called the product rule. Then you know when to apply. We apply the product rule when we multiply. Product means multiply, right? We could only apply product rule when we multiply exponential expressions with the same base. Okay, try this. Can you help me to simplify this? Can you simplify x cubed times y squared? You're right, Joe. The reason we can't is because they do not have the same base. Yeah, it's already simplified, exactly. The reason this expression, the reason we cannot use the product rule to simplify this expression is because it's already simplified. And the two parts is not actually two parts, is one term only. They do not have the same base. It's different from number 1. They do not have the same base, so we cannot apply the rule. The rule is not applied. It's not applicable in this case. All right, guys, so let's now look at number 4. Number 4, we have 2a to the power of 7, b to the power of 2, times parentheses, that is 3a, b, fifth. I'm going to use two different methods. To simplify this expression. Okay. First method, either method you would have to see clearly and correctly the structure of the expression. I see one product. In a product, I have factor 2. I have 7 a's. 1, 2, 3, 4, 5, 6, 7. And I have a b square, I have 2 b's, right? And then I have another constant factor, -3. And then I have another a, and then I have a b to the 5th, give me 5 b's. 1, 2, 3, 4, 5. All right? Yeah, so you need to see this expression actually is one big multiplication in which we have this many factors. They are multiplied together. By the commutative property and the associated property of real numbers, multiplication of real numbers, the order of those factors in the multiplication doesn't matter. Doesn't matter. So we can switch the order. We can put the two constant factors together, and then we can put those a's together. 1, 2, 3, 1, 2, 3, 4. So 7 and then another 1. So it's eight of them. 1, 2, 3, 4, 5, 6, 7, 8. And then we're gonna put these 2 b's and with the other 5 b's. So 2 here, we have 1, 2, 3, 4, 5, 5 there. So we have 7 b's. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to continue simplifying the expression. 2 times -3, -6. And this part is a repeated multiplication. The reason we have the exponential expression is because when the number of repeated factors in a repeated multiplication too big, it's really not convenient to express it like this way. So we can rewrite this repeated multiplication as exponential expression a to the power of 8, because we have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Right? 7 from here, 1 from here, 8 of them. And then how many b's do we have? 1, 2, 3, 4, 5, 6, 7. 7 b's. Because we have 2 from here, we have 5 from here, so it's 7. So that's one way to process this problem. I want you at least know how to do this. Really, we do not use any fancy method. All we use in this method is the definition of exponential expressions. Exponential expressions is a repeated multiplication. Let's see Amanda's answer and Jules' answer. -6, a to the power 8, b to the power 7. Very good. When you type exponential, you actually need to type this symbol. Where is the symbol on the keyboard? On the keyboard is above 6. This one, yeah. Remember to exactly. Shift 6. Yeah, we should write -6. If you really have to type in without the mathematical editor, you would have to write -6, a to the power shift 6, 8, and b to the power. Sometimes it's better to write multiplication symbol here. Times b is shift 6 to the power 7. Like that. Yeah, but I know you understand that. Very good. So that's the first method. The second method is there's a reason we learn the formulas, right? Because those formulas are good tools. Are good tools. Those formulas are good tools and can save you effort. Let's do this question with formula. So number 4, we have 2a7b squared times -3ab5. So same with earlier, we still need to see clearly and correctly the structure. what structure of this expression? This expression is just a multiplication, one multiplication with many factors. So we can write 293 together, and then write a to the power 7 and a together, and then b squared with b fifths together, because the order of those factors in the multiplication doesn't matter due to the commutative property and associated properties of real numbers when it comes to multiplication. So here 2 times 93 is -6. A to the power 7 times a to the power 1. This is the time we are able to use the product rule. We are multiplying two exponential expressions with the same base. So we can keep the base, add up 7 plus 1, the exponent. And then we see b squared times b to the fifth. And that's again when we could apply the product rule. So because we have a multiplication of two exponential expressions with the same base, so we just keep the base b and add up the two exponents. 2 plus 5 is 7. Same answer, but this way is a lot faster than than the first method. Okay, at least you need to know the first method in case you, because when we learn more formulas, you're gonna start to get confused. At least you can use the most basic definition to get it done. All right, any questions about the first formula or the first rule, the product rule? Ask yourself two questions. When do we apply this rule? Three questions, I'm sorry, three questions. What's the name of the rule? What's the name of the rule? Why is the name? Why the keyword is that? And second question, when do we apply it? When do we apply it? Third question, how do we apply it? All right, three things for the first formula. What is the product rule? Why is the name the product rule? When do we apply it? The name kind of tells us when do we apply it, and how do we apply it? Remember, when we apply the product rule, we add exponents, okay? We do not multiply the exponents, we add them. Okay, if you have no question, we move to the next rule. I'm going to start from the question, solve the actual problem. Look at the first one. We have x to the fifth over x cubed. Our goal here is to simplify this expression. Our goal here is to simplify the expression. Let me show you how. I'm going to use the definition again. The definition we went over at the very beginning today. Exponential expressions are just repeated multiplications. I'm only using that definition here to process this problem. X to the power fifth is an exponential expression. It is a repeated multiplication. It's actually is equal to 1, 2, 3, 4, 5. 5x multiplied together. That is the numerator. Denominator is x cubed. Exponent is 3. It is an exponential expression. As a repeated multiplication, it is x times x times x, 3x. Okay? Remember, for fractions, we have two properties. I believe I mentioned the two properties. One is called the multiplication property, the other is called the division property. The division property tells us if the numerator and the denominator of a fraction have a common factor, we are able to cancel them. You probably know, you should know you can do it. The reason we can do it is because of the division property. So this x cancel this x, and this numerator x cancel this x, This x cancel this x. So the numerator only have 2x left. The denominator has none. Okay, none x means the denominator is going to be 1. Please don't put a 0 there, okay? Please do not put a 0 there. The denominator is 1. The answer is going to be x squared. It's x squared. Perfect. Thank you, Amanda. Very good. All right. So now I'm gonna work on the second question. Use the same thing, same definition. So the second question is a little bit different, but very similar with the first question. The numerator and denominator are interchanged. Okay, let's see how do we do this. Numerator x cubed 1, 2, 3. Denominator x to the power of fifth 1, 2, 3, 4, 5. 5x's. By the division property of fraction, cancel. So we have 1 in the numerator. Denominator is x times x, and that gives us 1 over x squared. Okay? 1 over x squared. 1 over x squared. Perfect. Exactly. If you can use a parenthesis to frame x squared, that's even better. But we normally don't really type expression like that. This is about mathematics. It has its own format. A lot of platform doesn't really support instructors like type those mathematical expressions. Okay, so what I wanna try to give you through the two questions is, like earlier, what if we have x to the power 200? And this method is going to be very slow, right? We have to write 200x multiplied together. So here what I want to do is to show you the pattern. We are question number 1 and question number 2. Both of them have the same structure. What structure? They are both division of two exponential expressions with the same base, or quotient. Quotient is the result of division. Quotient of two exponential expressions with same base. This one, numerator is exponential expression with base x. Denominator is exponential expression with base x. Same with here. So that's so those two expressions have the same pattern, same structures. Same structure. When we dividing two exponential expressions with the same base, we could actually have a faster way to get it done. Look at the first question. Numerator has exponent 5. Denominator has exponent 3. And the result is x to the power 2. And the 2 is coming from using 5 to minus 3. Okay? The reason is because in the numerator we have more x's. So the denominator x is going to be all gone. And we end up with the 2 x's because that's the difference between the numbers of x's in the top and the bottom. So we could simply use the numerator exponent minus the denominator exponent. Keep the base and use the exponent in the numerator to minus the exponent in the denominator. Okay? But what if we have more x's in the bottom than in the top? Like question number 2. The bottom exponent is 5 bigger than the top exponent 3. In this case, we are going to use the bigger exponent to minus the smaller exponent, but keep the result x squared on the bottom. The reason we have x squared on the bottom is because we have more x's in the bottom than in the top. In the numerator, in the top, we're gonna have no x. They are gonna all gone, all be cancelled. So the leftover x is gonna remain on the bottom. That's the reason we can use the bigger exponent to minus the smaller exponent, and we just need to write x squared on the bottom in the denominator. So here is the rule. Here is the rule. When we divide two exponential expressions with the same base, what we can do is this. Okay, this is what we do. We make sure they do have the same base, and then we look at which part has a bigger exponent. In question number one, if the in question number one, the numerator has a bigger exponent, so the numerator is dominating. Okay, so you're gonna have to see which part is dominating. Is the numerator dominating or denominator dominating? Since in question number one, numerator is dominating, we are going to use the numerator exponent to minus the denominator exponent. So we have x squared. And for question number two, the denominator is dominating. So first you have to double check they do have the same base. And since the denominator exponent is bigger, the denominator is dominating. Since it's dominating, so we are going to use 5 minus 3, but the result gonna stay. The result gonna stay on the denominator. Do you see what I'm talking about here? What if we use the numerator exponent to minus the denominator exponent? Number question 2. Then we should have 3 minus 5. We would have a negative exponent. Okay? Knowing this is correct as well, and they are equal to each other. All right? Let me read a cue for this rule. What rule? The second rule we are learning is called a quotient rule. Quotient rule. Quotient is the result of division. The name tells us when do we apply the rule. When do we apply the rule? When we divide. Divide what? The whole chapter is about exponential expressions. When we divide exponential expressions with the same base. And how do we apply the rule? We always use the numerator exponent to minus the denominator exponent. Sometimes you might have negative exponent, and later we're gonna learn a new formula and could help us to get rid of the negative exponent. If you want to avoid having negative exponent, then you use the rule that I state, a different version of this rule. How do we apply it? If the denominator is dominating, you just use the denominator exponent to minus the numerator exponent, and keep the result on the bottom. The numerator is going to be 1. Let me know if you have any questions about the two questions. The formula is right here. The name of the rule is called the quotient rule. When do we apply it? When we divide. Divide what? Divide two exponential expressions with the same base. How do we apply it? We keep the base and use one exponent to minus another exponent. And the result either keep on the top or on the bottom, depends on which part is dominating. If the numerator is dominating, like number 1, we keep x squared on the top over 1. Over 1, we don't really write it out. If the denominator is dominating, we keep the result on the bottom. So 1 over x squared. And let me know, is that clear, guys? Is that clear? Okay, thank you. And now please answer this question. Can we use the quotient rule? Okay, thank you. Oh, Jill is answered. Jill is okay. Can we use the quotient rule to simplify number 3? And why? Why? If you think so, if you think yes, then why is yes? If you think no, why is not? Jill said because it's already simplified. Exactly. We cannot use the quotient rule for number 3 because the two exponential expressions do not have the same base. They do not have the same base. I put a question there just to remind us when can we apply the rule? When we divide the two exponential expressions with the same base. If they do not have the same base, then we can't. Bases are different. Exactly. Because the base, yeah, it's called a base. Base are different. Very good, very good. And now we're going to process a bigger question, more complicated question. We have number 4. It is 80. I can make it bigger. 80. So we are looking at it here, okay? Number 4. We are looking at a quotient. Quotient means a division. This is a fraction bar, numerator, denominator is a division. The numerator has 80 times a to the power of 8, b to the power of 2. The denominator is negative 16, a, b fourth. I'm going to use 2 different methods to show you how do we simplify this expression. The first method, take the longer route, but you need a less tool. You don't need a lot of tools. So we write 80 as 16 times 5. And a to the power of 8 is 1, 2, 3, 4, 5, 6, 7, 8. Luckily, we don't have 88s. That's why later I'm going to show you the benefit of the formula. And then b squared is 1b and another b. Denominator, negative 16. So 16 times negative 1, or negative 1 times 16. And then we have 1a here. We have b to the power of 4. 1, 2, 3, 4. 4 b's. Now we are going to use the division property of fractions to cancel the common factors from the numerator and the denominator. 16 cancel 16, right? This a cancel this a. This b cancel this b. This b cancel this b. And we have canceled whatever we can cancel, right? Yeah, no more. No more. So let's organize the leftovers. Numerator 16 is cancelled, we have 5 left. Besides the 5, we have how many 8's left? We have 1 cancelled only, so we have 7 left. 1, 2, 3, 4, 5, 6, 7. And we do not have any b's. They all gone. Denominator, we have negative 1. The 16 is cancelled. A is cancelled. 2 b's are cancelled, but we still have 2 b's left. So 1, 2. And now we can simplify. Numerator is 5. We can write this repeated multiplication as an exponential expression. 1, 2, 3, 4, 5, 6, 7. So a to the power of 7. And the denominator is negative b squared. And this is good enough. But you can also write this as negative. You can write a negative sign in front of the quotient. I mentioned this formula before, right? If I have not, or if you have not included in your book, notebook, do this. Negative a over b, b is non-zero, denominator can never be 0, equals negative a over b equals a over negative b. The negative sign of a fraction can be moved in the numerator, go with the numerator, or move in the denominator, go with denominator. So that's the reason the denominator has a negative sign, and I can move it in front of the fraction. And that's the result, simplified form. Simplified form. All right? Everybody, I believe everybody can do that. Everybody can do this method. Just don't get bored and don't lose an A when it has a bunch of A's. Count it correctly. And of course, we have a better method, right? That's why we learn more tools. We have better methods. We can use the quotient rule we have just learned to simplify this expression. 80/16, that part, if you have 80 in the numerator, -16 in the denominator, you're going to have -5. Okay? And then you have a to the power of a over a to the power of 1, actually. And then you have b to the power of second, you have b to the power of fourth. So we keep 95 here. Use the quotient rule. This is a division. We know we're going to use the quotient rule because it's a division of two exponential expressions with the same base. And the numerator dominating. Numerator is dominating. So we use 8 minus 1 and leave everything on the top. On the top, over 1, you don't really have to write over 1. Okay? It's going to be on the top. So the 95, hold on. The 95 actually is on the numerator. We keep it on the numerator. And 8 minus 1 is 7. And the numerator is dominating, so we keep 8 to the power 7 in the numerator. And here, we have another quotient of two exponential expressions with the same base. But the denominator is dominating. So we know we're going to have something in a denominator. We use a 4 to minus 2, and we keep the result on the denominator, b squared. It's a lot faster to get the same result. Okay? And this process, the first method is actually show you why the quotient rule work. Hold on. Let me think the correct English to say. To show you how the quotient rule works and why it does work. Questions? Number 4. Ask yourself, what's the name of the second rule we learned? What's the name of it? The first rule is a product rule. Second rule is a quotient rule. And when do we use it? When do we use it? And how do we use it? Yeah, that's the 3 questions you need to answer. Can it still be written as -5a to the power 7? You're going to have a slash at least. A slash in front of b. Because the b squared is on the bottom. Yeah. B squared is on the denominator. That's a very good question. All right, guys. Next up, new formula. And as I said, I'm going to start from look at the question here. Number 1, we have x squared to the power of 3. All right, x squared to the power of 3. And look at the structure. What I see, this expression is one exponential expression. One exponential expression. And what's the base of the exponential expression is the yellow thing in the parentheses. And the exponent is 3. Yeah, the yellow is the, okay, that's correct, but let me explain. The yellow part is the base. What I see, this is one exponential expression with the yellow or the parentheses as the base. Since the exponent is 3, we use the base 3 times in the multiplication, right? Repeat the multiplication. So yellow, yellow, yellow. x squared, x squared, x squared. Okay? And x squared is 2 x's multiplied together. X squared is 1, 2, 2x multiplied together. X squared is 2x multiplied together. And we can remove those parentheses because of the associated property. So we have x, 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 x. We have 6 of them, right? This is a repeated multiplication with 6 is used as a factor 6 times in the multiplication. So we can write a repeated multiplication as exponential expression, and we have x power 6. Jill has the correct answer. And the first one to give us the correct answer. Very good. Of course, we have a faster way to get it done. It is to apply the third formula we're going to learn. It's called the power rule. Okay, power rule. Firstly, let me explain. When do we apply power rule? When do we apply power rule? We apply power rule when we need to simplify an expression with a kangaroo structure. My spell might be wrong, but you know kangaroo is a type of animal in Australia, right? My drawing is also bad. Okay, so you know kangaroo, mommy has a bag, pouch in front of her belly, right? And her baby kangaroo would sit in the pouch. So our power rule applies when we need to simplify an expression with that type of structure, like a kangaroo structure. So this is the yellow part is like the pouch of the mommy kangaroo. And the pouch, inside the pouch, we have a baby kangaroo. So basically what I'm trying to say is the structure of this type of expression is a power or exponential expression whose base is also an exponential expression. Yeah, correct English. What type of structure? We apply the power rule when we need to simplify an expression whose structure is an exponential expression whose base is also an exponential expression. But it's not easy to say the sentence. So you want to just remember is a kangaroo type of structure. The baby kangaroo is in the pouch of the bigger kangaroo, mommy kangaroo. And in this type of expression, we have one base. X here is the base of the base. That's, I believe this is correct English. X here is the base of the base. Is the base of x squared, and x squared is the base of the whole expression. So x here is the base of the base. So we have one base and 2 exponents by layers. This is inside, this is outside. Okay. If we have an expression with that kind of kangaroo structure, and what we can do is this: we keep the base of the base, and we multiply the 2 exponents, and we got the same result. Multiply the 2 exponents, and we get the same result with earlier when we use the definition. We get it done with definition. Okay, so let's look at the Q, application Q. Focus on answering 3 questions. Sorry. Focusing on answer 3 questions. The third formula was the third rule. What's the name of it? What is the name of it? Power rule. Power rule. Power rule is the name. And then when do we use it? When do we apply power rule? When we need to simplify a kangaroo type of expression. There's a baby kangaroo sitting in the pouch of the mommy kangaroo. And how do we apply it? We keep the base of the base. We keep the base of the base, and then multiply the two exponents. So that's how do we get that done. All right. Try this. Try y3, 4. Y to the power 3 and then to the power 4. Awesome. Exactly. Huh? X to the power of is y to the power 12. Very good. Y to the power 12. Let me challenge you a little bit. Make it more complicated. It's like grandma kangaroo. I don't know. I don't think that works. But let's imagine there's a grandma kangaroo with mommy kangaroo in a grandma kangaroo pouch and a baby kangaroo in a mommy kangaroo pouch. So can you simplify this expression? Y to the power 3, and then raised to the power 4, and then raised to the power 5. Exactly. Awesome. Y to the power 60. Perfect. Very good. Awesome. So that's the third formula we learned. It's called a power rule. 3 questions. Name of it, power rule. And probably because the structure is a power structure. When do we use it? Kangaroo structure. How do we use it? We keep the base of the base and we multiply. Very, very important. Multiply the exponents. Okay, tell me please, what's the result of number 2? What's the result of number 2? I think Jill was going to answer this question and trying to beat us with the speed. X to the power of what? 6. Awesome. Thank you, Jill. Is correct. It doesn't matter. By the way, it doesn't matter the exponent is negative, okay? Yes, it is -2, and then here's -3. We process them the same way. Keep the base of base x and then multiply -2 with -3. We have 6. So x to the power 6. Very good. And help me out to simplify number 3. Question number 3. What's the result of number 3? X cubed times x squared. X fifth. Do we use the power rule for number 3? Did we use power rule for number 3? No. What rule did we use? What rule did we use for number 3? No kangaroo. Exactly. Product rule. Perfect. Thank you, Jacob. Exactly, Amanda. Very good. The reason I put this question here is because it is a common mistake. Common mistake. People confuse product rule with the power rule. It happens all the time. They don't know when to add the exponents, when to multiply the exponents. So x cubed times x squared, x cubed to the power 2. So let me highlight them, okay? I highlight this yellow and highlight this as green, just for convenience of reference. They are different. They have different structures. The green one has the kangaroo structure. The yellow one are 2 kangaroos hold hands together. Dad and mommy and dad. Mommy and daddy hold hands together next to each other. And this is just the mommy kangaroo and the baby kangaroo. So they have different structure. So different rules apply. We use the product rule for the yellow. When we use the product rule, we add the exponents. 3 plus 2, 5. The green one, we use the power rule for the green. When we use the power rule, we multiply the two exponents. So you might want to consciously emphasize the two things. It's pretty interesting. When you apply the product rule, you add the exponents. When you apply the power rule, you multiply the exponents. I think confusing part is that people think product rule, now I'm going to multiply the two exponents. No, you don't. When we apply product rule, we are actually adding the exponents. When we apply the power rule, we are multiplying the exponents. The reason I've already displayed the reason. All right, guys, do we have any questions about number 4, which is the power rule, the third formula we learned? 3 things. What's the name? What's the name related to kangaroo? Power rule. When do we apply it and how do we apply it? Perfect. Let's continue. Next up, we have 2 more. We have power of product and the power of quotient. In our book, by the way, in our book, they call those 2 formulas also as power rule, but I don't like it. I give them different names just to specify them better. Just have to really pay attention. Yeah, I agree. So the next formula is called the power of a product. The name of the formula explains the structure of the formula. Power of a product. And the application Q is also pretty catchy. It's called catchy, right? Pretty rhyme. This kind of rhyme. The application Q of this formula is also pretty easy to memorize. Power of a product equals the product of powers. Firstly, I'm going to use the question to explain. So let's use the question to explain. Number 1, x times y to the power of 3. This is a power of a product. So firstly, we need to see or agree on the structure of this expression. It is a power of the base is a product. So this is the power of a product. Power, third power, right? Third power of the base. The base is a product. So the expression we are looking at right here is a power of a product. I'm going to show you that expression equal to the product of powers. I'll explain later. So the structure, the base is the whole thing in the parentheses, right? The base is the whole thing in the parentheses. Since it's a cube, third power, we use the base, the parentheses three times in the multiplication. And in the multiplication, we have x times y, x times y, x times y. Remember, we have the commutative property, associated property of multiplication of real numbers that allow us to mess up or rearrange the orders of the factors in the multiplication. So what we can do is, so that's one product, is to switch the order and write the 3 x's together and then write the 3 y's together. We can do that, right? And the 3 x's gives us x cubed. The 3 y's gives us y cubed. And then look at the structure of this expression. The structure of this expression is a product of powers. And this is a power of a product. I explained third power, right? Third power of the base. The base is a product, so power of product. And the result on the right side, we have a product. The bigger structure is two powers at multiply together. So product, hold the hands together, right? Product of powers. The first power is x cubed. The second power is y cubed. They multiply together. And I want you to really see the structure. On the left side, we have a power, specifically third power, of a product, x times y. On the right side, we have a product of powers, the multiplication of x cubed and y cubed. I proved for you actually, right? I proved for you the application Q actually. Power of a product equals product powers. When we actually apply it, I want you to remember. Firstly, you need to remember power of a product could be written as product powers. And how do we do it? All we need to do is to apply the exponent on both factors in the base. We can apply the factor x, we can raise x to the power 3, and then multiply y to the power 3. The parenthesis is a grouping symbol, right? Remember, grouping symbol is not really distributive property, but actually the idea is similar with distributive property. Once you remove the grouping symbol, the exponent is gonna fall on the shoulder of each member of each factor. X cubed times y cubed. Perfect. Thank you, Jill. Exactly. So that is a rule. I do not call the thing as a rule. I call that as a formula. It's called the power of a product. And the application Q is power of product equals product powers. Let me know what I have explained so far regarding this formula clear enough. And then we're going to go apply it. No question? Let's apply number 2. Let's apply it to solve number 2. Let me erase those. Power of product equals product powers. I think it's pretty right. All right, so we have, this is x cubed times y cubed. And number 2 is -2x to the power 4. Our goal here is to simplify. Simplify, you would have to keep going. And also, we sometimes do have to use parentheses in order to get a correct answer. So what I see here is, I see a power of product. I see a power of product. What color? Blue. Blue? Yeah. I see a power of a product. I see a fourth power of a multiplication. Power of product. And the product has two factors, the green and the blue. So by the power of a product, the formula, power of product equals product powers. So we're gonna apply the first power on each factor. We're gonna apply the fourth power on each factor. Apply on the green times apply on the blue. Let me apply the color. So the first power apply on the green, multiply by apply on the blue. But you are not completely done yet. So Joe, this parentheses, very important. This parentheses that frame the -2 is very important, is necessary. And we can keep going to simplify. We're not done yet. What is -2 to the power 4? Oops, phrasing. Oh, here. So what is -2 to the power of 4. We had a problem like that earlier, the very beginning. -2 in the parentheses to the power of 4. -2 in the parentheses to the power of 4 equals 16, right? It's -2 times -2 times -2 times -2. 16 times x to the power of 4. That's the answer. That is the answer. Positive 16. Yeah, exactly. Positive 16 times x to the power of 4. Awesome. Very good. All right, let me write the answer here. 16 x to the power of 4. Try number 3. Try number 3. And let me know your answer. That's, yeah, it's number 2. Number 3, negative y to the power of 5. Think about when you type in the chat, how do you know, what's the correct way to type it and to show the correct result? By the way, this can be seen as -1 times y to the power of 5. It is a power of product. -y is -1 times y. It is the fifth power of a product. -1 is the first factor, y is the second factor. -y to the power of 5. Awesome, exactly. Your answer is correct, Jill. Perfect. So we have -1, yeah, power of a product equals the product of powers. So we apply fifth power on the shoulder of -1, and apply the fifth power on the shoulder of y. -1 to the power of 5 is -1 times -1 times -1 times -1 times -1. Since the 5 is odd, ODD. This is a positive, positive. One more left, so it's a negative. -y to the power of 5. Right? Negative, yeah, exactly. Thank you, Felina. Perfect. Try number 4. Try number 4. And tell me the result. Perfect. Exactly. You guys are great. Okay, so I'm going to show you 2 different methods, all right? So number 4, we have x squared times y to the power of 4. The first method is to use the formula. And knowing that we are looking at a power of a product. The product has 2 factors. The first factor is the green, the second factor is the pink. So by the power of product formula, power of product equals product of powers. We have that equal to the green, x squared as a whole thing, green to the power of 4, times the pink, y to the power of 4. And then we're not done yet. What is this? Do you see the kangaroo structure? When you see a kangaroo structure, you need to know we are going to apply the power rule, right? How do we apply the power rule? We keep the base of the base and multiply the 2 exponents. 2 times 4 is 8. and then copy down y to the power 4. Exactly, the result is x to the power of 8 times y to the power 4. In case some students don't remember this or want to use a more intuitive method, this is what you can do, okay? So the whole thing is one exponential expression. Whatever in the base is the base. Whatever in the parentheses is the base. So we have parentheses times parentheses times parentheses times 4 times, right? Because the exponent is 4. In each parentheses, the base is x squared y, x squared y, x squared y, x squared y. And x squared y is 2x times together and 1y. And this is x times y. This is x times y. This is x times y. And then we count it. How many x do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have x to the power 8. And how many y's do we have? 1, 2, 3, 4. So we have y to the power 4. So either way, you should be able to get it done. Even you don't know what is the power rule. Even you don't know what is the power of product. At least you need to know what is the exponential expression and how do we rewrite the exponential expression as a repeated multiplication like this. Okay, try number 5 and let me know your answer. You want to simplify the numerator and denominator separately? First, 25 over x. Yeah. 25 over x. Amanda's answer is correct. Okay, let me show you what happened. Is a lot of complicated than the previous questions, right? So we gonna simplify the numerator and denominator separately. Let's look at the numerator only. The numerator is a power of a product. I hope you see it. Power of a product. The product is 5 times x. So power of a product equals the product of power. So we have 5 to the power 5 times x to the power 5. We apply the exponent on each factor. Put the 5 on the shoulder of 5, put the 5 on the shoulder of x. And we can do the same thing to the denominator. Okay? To the denominator also a power of a product. And 5 is the first factor, and x squared is the second factor. So we have 5 to the power 3 here, and x squared in the parentheses to the power 3. So firstly, that's the first step. I use the power of a product to rewrite both top and bottom. Okay? And then we see a kangaroo doing. Copy the numerator, copy the denominator 5 cube, and then we see a kangaroo here. X squared to the power 3, x squared and then to the power 3. So by the power rule, we have that part equals x cubed. And then what do we do? We're going to use the quotient rule, okay? We're going to use quotient rule. 5 to the power 5th over 5 to the power 3rd. We are actually looking at a quotient of two exponential expressions with the same base. Do not worry about the x part yet. See 5 to the power 5th here and 5 to the power 3 here. And then multiply x to the power 5th here, x to the power 6 here. You can see that as the multiplication of two parts, or you can just handle the fraction like this. 5 to the power 5th over 5 to the power 3. Numerator is dominating, so 5 minus 3 is 2. So we have 5 squared on the numerator because the numerator is dominating. For the x variable part, x fifths in the numerator, x sixths in the denominator. Denominator is dominating, so we're gonna have something. We're gonna have leftover x in the denominator. So 6 minus 5 is 1. We have 1 extra x in the denominator. 5 squared is 25. 25 over x. Unless you really enjoy the first method and you can handle, I believe some of you don't really understand what's going on. So this is what you can do, okay? You can do this, 5x to the power 5th, and this is a 5x squared to the power 3. Numerator is, you can write the numerator as 5x, 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 5x. Right? Repeat the multiplication. Count numbers, don't miscount. 1, 2, 3, 4, 5. Denominator, 3 of them. 1, 2, 3. The base is used 3 times in the multiplication. And 5x squared is 5x, x, 5x times x, 5x times x. And now you can cancel whatever you can, right? And you can cancel this 5 with this 5. This 5 with this 5. And this 5 with this 5. And you can cancel this x with this x, this x with this x, 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 this x with this x, and this x with this x. And then you look at the numerator. Everything is cancelled except this 5 and this 5. And the denominator, everything is cancelled except the last x. So 5 times 5 is 25. Denominator is x. Sometimes even this method even better, like easier to get you to the correct answer. And let me know if I'm clear. I'm not against you using this method at all, okay? You can use this method for sure. Of course, I hope you know both methods. Okay, perfect. Continue. Next formula. If we have a power of product, you will not be surprised. We also have a formula that is about power of quotient. Let's look at number 1 first. Number 1, this expression we're looking at is a power of quotient. Okay? Third power, specifically third power of the base. The base is a quotient. Quotient is the result of division. So x divided by y. So hope you see that this expression you're looking at is a power of quotient. I'm going to rewrite that expression, the power of quotient, as quotient of powers. This is what I do. So I'm going to use the base 3 times in a repeated multiplication. So that expression basically is a cube. The base is the parentheses. The base is in the parentheses. I multiply the base 3 times. And we have x over y here, x over y here, x over y here. So that is x over y times x over y times x over y. How do we multiply fractions? We multiply cross. Remember that, right? Numerator times numerator, x, x, x. Denominator times denominator, y, y, y. So the numerator is x cubed. Repeat the multiplication. Denominator is a y cubed. Repeat the multiplication. And this is a quotient of powers. It is a quotient first. Numerator is a power, denominator is a power. I just proved for you. Technically, the proof is not very strict, but using specific numbers is easier for people to understand than using letters. The left side is the power of quotient, the right side is the quotient of powers. Turns out they're the same. Exactly, slash. Perfect, very good. That means if we have a power of quotient, we are able to rewrite it as a quotient of powers. Again, the parentheses is a grouping symbol. Once we dismiss the group, the exponent 3 gonna apply on each member. Member here is on the second floor and the first floor, like the top and the bottom. So the third power apply on the top and also on the bottom. Okay, so let's use this formula to simplify question number 2. Question number 2 is x over 2 to the power of 3. How about you give it a try? I will use this formula to simplify this expression. This expression is a power of quotient because the base is a quotient. Awesome, very good. Thank you, Joe. Exactly. Very good. Power of a quotient equals the quotient of powers. 2 cubed is 2 times 2 times 2, 8. I have another question. Am I able to write this result like this? Is this the same way as 1 over 8 times x cubed? My question here is, could I write x cubed over 8 as 1 over 8 times x cubed? Can I? Are they the same? Yeah, they are the same. And why do I need to write this write like this? Because this is a term. Remember term. This format is a term format. 1 over 8 is a coefficient. Coefficient. X cubed is the variable part. Very good. Perfect. Try number 3. Try number 3. Perfect. Thank you, Amanda. Exactly. Number 3 is a power of quotient as well. When we dismiss the parentheses, the second power gonna go with the numerator and the denominator separately. So we can apply the second power on the numerator and apply the second power on the denominator. And don't forget to use the parentheses to frame y to the power of 7 to indicate that's one whole thing and as the base of the square. 2 to the power 2 is 4. And this is a kangaroo, right? Kangaroo structure. When we have a kangaroo structure, we apply power rule. When we apply power rule, we multiply the exponents. 7 times 2 is 14. And that's it. Again, if you really like in a cloud, not understand what's going on, you can just only use the definition of exponential expressions. So basically, you are looking at a square, and the base used twice in the square, right? So it's 2y to the power 7, 2y to the power 7. And then 2y to the power 7, 1, 2, 3, 4, 5, 6, 7. Multiply by 2 over y to the power 7, 1, 2, 3, 4, 5, 6, 7. Right? And then you multiply all together. You can multiply them together. 2 times 2 is 4. And then in the denominator, you have 7 y's here. You have 7 y's here. You have in total 14 of them. 14 of them. All right. So that's today. We're gonna stop here because we have more formulas to go and we are running out of time. Jacob mentioned, I think it's Jacob or I don't remember. You mentioned to ask some question about your exams, right? I can answer your questions after I stop the recording. So that's for today, guys. Let me stop the recording. Actually,